All right, so let's finish this up. We're going to do 6.6, properties of kites and trapezoids. Okay, kites and trapezoids. Okay, a kite is a kind of a rhombus looking thing, right? It's like kind of a rhombus looking thing, as in they meet in 90 degrees like this, as a rhombus does, but you have one side that is a lot larger, a lot longer than the other side. So that's why it's a kite, right? It's a kite, right? So this guy and this guy would be the same. This guy and this guy would be the same type of thing. That would be a kite. And a trapezoid is where you have one pair of parallel lines, the others that are not, right? That's a trapezoid, okay? So this would be a trapezoid, okay? Just to kind of review what indeed a kite and a trapezoid is. So that's what it looks like. Okay, so let's go to 6.6-1 on page 439. If a quadrilateral is a kite, then its diagonals are perpendicular. Okay, diagonals are perpendicular. Okay, so just like I showed before, these here are going to be perpendicular, like that. This guy and this guy are congruent. These two are congruent. That's a kite. And 6.6-2, if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent, okay? So in other words, this guy and this guy are going to be congruent. These two obviously are not, only just this one pair is congruent, okay? All right, so that's that. Let's go to example number 1. Alicia is using a pattern to make a kite. She has made the frame of the kite by placing wooden sticks along the diagonals. She also has cut 4 triangular pieces of fabric and has attached them to the frame. To finish the kite, Alicia must cover the outer edges with a cloth binding. There are 2 yards of binding in one package. What is the total amount of binding needed to cover the edges of the kite? Okay. So she has a kite that she's making. The kite looks like this. And we have 16, 16, 13, 23. Okay, so we need the edges. Basically what we need is the perimeter, right? We need to find out what the perimeter is, right? So let's go ahead and look at this guy here. Since this is 90 degrees, this guy here, the length is going to be what? 16 squared plus 13 squared, the square root, right? This guy here is going to be square root of 16 squared plus 23 squared is going to be this squared, right? So, but this guy and this guy are the same, so I have 2 of these. And then I have this guy and this guy are the same, so I have 2 of these. So I'm going to end up with, so if I do this, what do I get here? I get, what is 16 squared? 196. So it says if I add these together, I get 425. I'm just going to go with this, 425. If I add these together, I get 740.
Mr. On?
Yes.
It's actually 22.
Oh, is it 22?
Yeah.
Thank you. Appreciate it. So it's 22 squared. Okay. So here we go. So are they breaking this? Do they actually break this down to, yeah, they do. Okay, so this is the same as 5 root 17. This guy is the same as what? What do we have here? 2 root 185. 2 root 185. So the total perimeter, the perimeter is going to be 2 of these. So it's going to be 10 root 17. Then 2 of these, so it's going to be 4 root 185. Okay? And if you do this, you're going to come up with what? 95.6 inches. Okay? And each packaging has 2 yards. 2 yards is how many inches? Anybody?
72 inches.
72 inches, right? 72 inches, right? So one packaging will not do the job, but 2 will, right? Because if I get 2 packages, then I'm going to get 144 inches, right? And that'll cover the 95.6. So the correct answer is I need to buy 2 packages. Okay? All right. Example number 2. Example number 2. Using properties of kites. In kite EFGH, and EFGH, FEJ is 25 degrees. So this guy here is 25 degrees. Then we have FGJ, this guy here is 57 degrees. Okay, find each measure. Find GFJ, right? So they're looking for this angle right here. But since I know this is 90 degrees, in this triangle, I have 90 degrees, I have 57, so this guy must be what? This guy would be 180 minus 90 minus 57, 23 degrees, okay? So that's 23 degrees. I'm 33, I'm sorry, not 23. 33. And then we have angle JFE. So same thing here, right? So since we have, this is 90 degrees here, this is 90 degrees here, this guy here, the angle is going to be 180 minus 90 minus the 25. That would be 65 degrees. Okay, and then GHE. GHE is this guy, which is congruent to this guy. And this guy would have been this guy plus this guy. And that would be 98 degrees. So this guy here is also going to be 98 degrees, right? Because you have to add these two together to get this complete angle, and that's the same as that angle, 98 degrees. Okay? All right, so that's the kite. Now let's talk about the trapezoids. So in the trapezoids, we have some nomenclature here first. I have, these two are parallel. The parallel lines are called the base. So this is a base. These others are called the legs. These are the legs, okay? And then you have the base angles. These two are base angles, and these two are base angles, okay? Okay, so if this angle and this angle are the same, we call that an isosceles trapezoid. Okay, just like you have an isosceles triangle where the base angles are the same. You have the isosceles trapezoid, where if these two angles are the same, then it's what we call an isosceles trapezoid. Okay, let's get the theorems there. 6.6-3. If a quadrilateral is an isosceles trapezoid, then each pair of the base angles are congruent, meaning that these two are the same, these two are the same, okay? So let's kind of see if we can draw something that looks more closer to a isosceles triangle. It's on my isosceles trapezoid. So now this guy, this angle and this angle are the same. This angle and this angle are the same. Okay. 6.6-4 says, if a trapezoid has one pair of congruent base angles, if these two are the same, then it is an isosceles trapezoid. Or if these two are the same, it is the same thing. It is a isosceles trapezoid. Okay. 6.6-5, if a trapezoid is isosceles, a trapezoid is isosceles if and only if the diagonals are congruent. So we have, again, if the diagonals here are congruent, it is an isosceles trapezoid. Okay. All right, so we have a few examples here. Let's see if we can go work through some of those examples. Example number 3. Using the properties of isosceles triangles, find angle Y. So I have an isosceles trapezoid that looks like this, and where these two are parallel, and I'm given that this here is 117, and I want to find this angle right here. Okay. So since this is 117, I know that this guy here is going to be 117 because these two are the base angles, they're the same. But I also know that these two are the same. So if we call this guy X, then I have X plus X plus 117 plus 117 has to be 360 degrees, correct? If I do that, I get what? 2x plus 234 is equal to 360. I subtract 234 on both sides. I end up with 126. So if I divide both sides by 2, I get 63, right? 63 degrees. Right, so we get that. I also actually, we could have just said that these two are supplementary. They add to 180, right? So I could have done that and said it was 63 also. Okay. And on the other ones, that was A. Let's look at B. If I look at B, I get this guy and this guy are parallel, and this guy and this guy are congruent, and I have RT is 24.1, this guy here is 24.1, and QP is 9.6, so from here to here is 9.6. I'm trying to find PS, this guy here. So this guy here, since this guy and this guy are diagonals and they must be congruent, this guy from here to here would have been 24.1. So this guy here is going to be 24.1 minus 9.6, right? Which would have been 14.5. 14.5. Okay, well, that's good. Let's go see if we can do example number 4. Example number 4, applying the conditions to find the value of Y so that it is a isosceles trapezoid. And we have this guy and this guy is parallel, and we are told that this guy here is 2y squared minus 25, where this guy here is y squared plus 24. Okay, so Ben, how would I solve this? What do I know about these base angles? Okay, that didn't work out well. Belen, what can I say about those two base angles?
I'm sorry, can you repeat the question?
These two angles, what can I say about these two angles in an isosceles trapezoid?
I'm not sure.
Okay, all right. Raquel, what can I say about those two angles? No, Raquel?
That they're congruent.
They're congruent, right? These two are the same, correct? That's good. So these two are the same, which means that 2y squared minus 25 is equal to y squared plus 24, right? Okay. So I have to collect the y squares together. So I'm going to move this guy over. So I'm going to subtract y squared from both sides. Y squared minus 25 is equal to 24. Now I'm going to add the 20, move the 25 over. So I get y squared is equal to 49, which means that y is equal to 7. Right, and is that what they asked for? Just the value of y? Okay, the value of y is 7. Or actually negative 7 works too, right? So it's going to be plus or minus 7, right? Since we are in y squareds here, right? Okay, so plus or minus 7. That was A. Let's get B. And in B, of course, I have a different drawing. And in B, I have and I have looks like this, where this guy and this guy is parallel. And I have J, K, L, M, and I'm told that JL is 5Z plus 3, and KM is 9Z minus 12. Find the value of Z so that it is an isosceles trapezoid. So for it to be an isosceles trapezoid, that means that this guy and this guy have to be congruent, which means that 5z plus 3 has to be equal to 9z minus 12. All right, so I have to solve this. McKenna, how would I do that?
You would add 12 to the 3 on the other side of the equal sign, and you get 15.
5z plus 15 is equal to 9z.
And then you would subtract the 5 and subtract it from the 9, and you get 15 equals 4z.
Go, good job. So z would be equal to 15 divided by 4. 3.5. Good work. Thank you. 3.75. Okay. So now, last on page 443, we have the mid-segment of a trapezoid, the mid-segment theory. Okay, the mid-segment theorem says that if I have a trapezoid where this guy and this guy is parallel, okay, and teach base and the line. So if I go ahead and cut this guy in half right here and cut this guy in half right here, and I connect these two together, okay, and we'll got A, B, C, D, X, and y, then in this case, xy is going to be equal to 1/2 of BC plus AD. In other words, I take this length and add it to this length, and if I add those two and divide it by 2, I'm going to get the mid-segment length. It's called the mid-segment because actually these are now all three parallel. They're all parallel. And you get that mid-segment right there. Okay? So that is the mid-segment theorem, right? The mid-segment theorem parallels to each base, and the length is 1/2 of the sum of the length of the bases. So if I add the two bases together, divided by 2, I get the mid-segment length there. Okay? So let's go ahead and see if we can go ahead and use this to do example number 5. Example number 5, I have S, M, R, S, T, U, and I have M and N. Find ST. So this is 31, this is 38, and I'm trying to find ST right here. Right? So if I use the mid-segment theorem, I know that x plus 38, the two bases, if I add and divide it by 2, I'm going to get the 31. Okay? So to do this, I would multiply both sides by 2, and I would get that. I move the 38 over, I get 62 minus 38, 24. So my answer would be 24. Okay. Oh, we're done. All right, so we're done. Any questions?